Viewers, welcome to another mathematics presentation. So in this presentation, I want us to look at a question that is coming from Travel Graphs. The question reads, a sprinter runs a race of 200 meters. Her total time for running the race is 25 seconds, ending at u meters per second. Below is this sketch, as you can see. So this is the sketch of the motion of the sprinter. So the first question is, calculate the acceleration in the first 4 seconds. So they want us to find the acceleration in the first 4 seconds. So this sprinter was accelerating from here up to here in the first 4 seconds. So how can we calculate for acceleration? So to calculate for acceleration, we are going to use the formula, which is acceleration is equal to final velocity minus initial velocity over time. Okay, so when you look at the sketch of the motion, the final velocity here, you have got the origin, which is 0. When going to time, we start from here. Going to meters per second, you start from here. So the initial velocity here is 0. Then the final velocity is 9. Then the initial time, it was 0. The final time is 4 in the first 4 seconds. Okay, so we are going to substitute. We are going to write where there is final velocity, the final velocity is a 9. So the printer started accelerating from here up to here. So the final velocity was a 9, the initial was a 0. So it will be 9 minus 0 over in the first 4 seconds, that is the time. So 9 minus 0, it will give us what? 9 over a 4. So from here, we can leave our answer as a decimal number. 4 into 9, it's 2, remainder 1. 4 into 1, it can't. You write a point, add the 0 there. 4 into 10, it's a 2, remainder a 2. So to this 2, we add a 0. 4 into 20, it's a 5. So this is acceleration. So I have 2.25 meters per second square. So whenever you are calculating for acceleration, you need to put the square on the units. So that is how we can write our answer. Let us now look at question B. All right, so let us now look at our question B. Our question B reads, calculate the distance covered in the first 20 seconds. So in the first 20 seconds, we are looking at from this 0 second up to 20 seconds. So the distance that we are considering, it's this part that I'm shading. Okay, this is the distance that we are considering in the first 20 seconds. So how do you find this distance? So you can see we have this is a triangle, then we have a rectangle right here. You can either find the area of this triangle plus the area of this rectangle, that will be the distance. Or you look at this shape. This shape that we have is a trapezium. So when we are looking for distance under the graph, the same as the area. Okay, so this being a trapezium, we are going to use the formula for the trapezium. So you say B, we say distance is equal to A plus B over 2, like this, in brackets, times H. So we need to find the value of A, the value of B, and the value of the height. So let us come back to our graph. So A will be presented by this from here up to here. We have A. Then from 0 up to 20, we have B. Then the height is from here up to this point. This is where we're going to have the height. So A is the difference in time between 20 and a 4. So down here we have a 20, here you have a 4. So the difference in time is, you say 20 minus 4. This will give us 16. So the value of A is a 16. Okay, then for B, difference in time from 0 to 20. So 20 minus 0, it's a 20. So B will be equal to a 20. Then the height from here up to here, what is the corresponding value? It's the 9. So the height from here to here, it's a what? A 9. So these are the values we're going to substitute in our formula. So let us go back. We are going to write distance is equal to, open bracket, where there is A, we are putting a 16, plus where there is B, we are putting a 20 over a 2 times, what is the height? It's a 9. Okay, then from here we can say distance is equal to, so 16 plus 20, this will give us a 36. Okay, that will be multiplied by a 9 over a 2. We have something like this. So here distance is equal to, so we can divide. We say 2 into 3, it's a 1, then remainder a 1. 2 into 16, it's 8 times 9. So 2 into 36 goes there 18 times, then times 9. So when we multiply, we're going to have distance equal to, so 9 times 8, it's 72. We write a 2, we carry a 7. 9 times 1, it's a 9. Plus that 1, sorry, plus that 7. So we have a 16. So meaning that 18 times 9 gives us 162. So this is distance. You have to put the units, meters. So this was our distance in the first 20 seconds, 162 meters. So I hope that it's clear. If you want, you can use the other method of finding the area of this triangle, then you add with the area of this rectangle. Okay, it will give you the same value. So let us look at our last question. So let us now answer our question C right here. The question reads, calculate the value of u. So you can see right here we have u. So they want us to find the value of this u. So how can we find the value of u? To find the value of u, we are going to consider this shape. Okay, we are going to consider this shape. Let me do this. We are going to consider this shape. Okay, this shape right here. So I want you to follow me nicely. So when you look at this shape, it's a trapezium. You can see the way it's looking as well. Okay, it is a trapezium. Okay, so this is the shape we are going to consider. So if it's a trapezium, we are going to find the distance under this graph, which is the trapezium. Okay, so if you remember, in the question they said a sprinter runs a race of 200 meters. So meaning the total distance of this motion was 200. Okay, it was 200. That was the total distance, 200 meters. So we did find the distance in the first 20 seconds from 0 to 20. And we say the distance is 162 meters. So since we are considering this shape, so we are going to find the distance in the last 5 seconds. Okay, in the last 5 seconds. So let us subtract. You say 200 minus 162. This will give us a 38 meters. So the distance in the last 5 seconds was 38 meters. Okay, so now we are going to use this formula of finding the distance under this graph. Okay, that's when we'll be able to find the value of u. So we are going to apply the formula. So the formula will be distance equal to, open bracket, a plus b cross times height over a 2. So we need to find the value of a and the value of b and the value of h. So let us go back to our shape. So here the value of we identify sides. So from here to here we are going to have a, then from here to here we are going to have b. Okay, then from here to here this is where the height will be, from here to here. So the height from here to here will be the difference in time. 25 minus 20, this will be a 5. So height is equal to 5. Then from here to here, we are looking at the corresponding figures, which is a u and a 0. So u minus 0, it's a u. A is equal to what? U. Then for B is from here to here. We are looking also at the corresponding values, 9 minus 0. So B is equal to a 9. So these values are going to substitute them in our formula, and the distance is equal to 38. So we come back to our formula. Where there is distance, we are going to put a 38 equal to, open bracket, where there is A, we'll put a U, plus, where there is B, we'll put a 9, cross, times, where there is height, you put a 5, over a 2. So from here, you need to open the brackets by multiplying with a 5. Okay, so I'm going to write 38 equal to 5 times u, it's 5u, plus 5 times 9, this is a 45, over a 2. So I hope that you are following. And then from here, we are going to, this is a fraction, this is not a fraction. We'll divide by 1 so that we cross multiply. So 2 times 38, okay, and 1 times this numerator. So 1 times 5u plus 45, we are going to get the same thing, which is 5u plus a 45 equal to 2 times 38, meaning 2 times 8 is a 16. 2 times 3, it's a 6, plus that one, 72. So 2 times 76, sorry, 2 times 38 will give us 76. From this stage, we can correct the like terms. 45, you go that side. We remain with 5u equal to 76 minus a 45. 45 is a positive. When it goes there, it becomes a negative. So from here, we are going to write 5u equal to 76 minus 45. This will give us a 31. So I want to find the value of u. So we need to get rid of the coefficient of u, which is a 5, by dividing both sides by 5, even here by 5. So that this and this will cancel. You remain with u equal to 5 into 31, because there are 6 times, remainder 1. 5 into 1, it can't. So you put a point. To this one, you add a 0. So 1 and a 0 becomes 10. 5 into 10, it's a 2. So what units are we going to put? We look at the graph where u is. So u is right here, which is in speed, meters per second. So where there is this value are found, we are going to put meters per second. This is our answer. So thank you so much, everybody. We've come to the end of our session. This has been your presenter, Mr. Mlenga. Bye-bye.